In this video, we'll talk about exponential functions on a very introductory level, talk about what they are, two different types, and generally just kind of their overall structure. So let's talk about format. Now, with exponential functions, there are a lot of ways they can be written, but the idea is your variable, x, is your exponent. In this case, I'm using b as an example, but that would be a constant. So for example, 2 to the power of x, let's say. And we're looking at what would that look like. So, couple of things here. If we're looking at exponential growth, which is our usual format for an exponential function. Typically, that's what we're talking about. However, there is also a decay. And we see this one a lot in science when we're talking about carbon dating and those kind of things. We use exponential decay. So, growth. There's a couple of cases. Either b is greater than 1, and x has to be greater than 1 as well. And what will happen is we'll have a graph, and it will start very low on the negative side, and it will just take off eventually. Because if we think about it, if we plot points, if we say took 2 to the x, well, plug in 1, you get 2. Plug in 2, you get 4. Plug in 3, you got 8. So on and so forth. And then eventually to the point, a couple steps later, you're already up to 64. It takes off. Decay, very different. So either b has to be greater than 1, no equal to, or greater than 0 and less than 1. So if it's fractional, if it's a decimal, and x again is positive or is greater than 1. Or we could have the case where b is greater than 1 and x is less than 0. If it's negative, that would result in like a fractional power, so to speak. So like if we had 2 to the negative 4, well, that'd be 1 over 2 to the 4th. So the idea being we have something, if we have our axis, it's going to taper off very, very gradually, but it's essentially the mirror of our red curve here. And the idea being that we have a fractional power. So like if I had 3/4 to the x power, that means that every time I'm taking 3/4 of 3/4 of 3/4 of 3/4. And we see this a lot with value. If we think about like a car, for example, it loses a lot of value in its first couple of years. And then it's really hard for a car to be worth nothing because eventually you can sell it for scrap. And then, likewise, you see it with carbon dating. It's very rare that something decays entirely to where there's nothing left at all. It's actually impossible, based on our laws of physics. And we see growth a lot when we talk about money, we talk about interest, things growing, we think about population, disease spread, a lot of things that follow exponential growth. These are two kind of very relevant formats. And it's worth kind of just talking about how each one can be created because, like I said before, there's a lot of ways to represent exponential functions, and there's a lot of ways that we can represent growth and decay. And the idea is, well, either it's taking off, it would be growth. If it's tapering down, it would be decay.